y les vamos a presentar unos ejemplos de proyectos que estamos haciendo en la inteligencia artificial y otras áreas para que un tipo de trabajo lo que hacemos. Tenemos muchos egresados de SemDep, desde, bueno, algunos de aquí de México, otros de Guadalajara, otros también de Tamaulipas. Y el trabajo que hacemos, pues básicamente es más como investigación aplicada. Así es, no son proyectos de implementación, no estoy edité normalmente aquí en Ciudad de México, no es el trabajo que nos gusta a nosotros. Nosotros nos vinimos aquí a México para poder traer nuestros proyectos que hacemos allá en California, pero hacerlos en México aquí mismo. Juan Pablo, ¿por qué no compartes un poquito de por qué tú te acabo de robar un poquito de lo que te encanta decir, pero preséntate a ti?
Hola chicos, ¿cómo están? Perdón por estar tarde, no nos dejaban entrar. Bueno, esto no es algo que les tengo que decir mucho a ustedes, ya estando en el SemDep, pero normalmente a mí me gusta decir de que hay una vida, no hay una vida personal separada de una vida laboral, solo es tu vida. Y dentro de eso lo que haces en un trabajo es un pedazo grande de tu vida. Entonces hay que hacer algo que uno disfrute. Y yo soy muy afortunado, a mí me encanta lo que yo hago. Yo hago mayormente sistemas distribuidos. Creo que me gusta más cómo me escucho sin el micrófono. ¿Ustedes me dicen? ¿Son mi audiencia?
¿Qué prefieres? ¿Trasfondo sin micrófono? ¿Sí? Perfecto.
Todo bien. Y pues la historia de mi vida, yo estoy confundido de dónde soy, pero crecí mayormente en Panamá y yo sabía que lo que yo quería hacer con mi vida era crear tecnología y avanzar el estado del arte. Y para hacer eso, Panamá no era opción. Entonces me fui buscando lo que yo quería hacer. Fui a Estados Unidos, allá estudié, de ahí me reclutaron de la universidad. Estuve en Silicon Valley por más de una década, hasta que hubo la posibilidad de venir a abrir un centro de desarrollo aquí en México, que es el único lugar que yo conozco para hacer lo que a mí me gusta hacer, con todas las ventajas de vivir en Latinoamérica. Y pues lo padre de vivir en Latinoamérica es que nosotros los latinos tenemos un sabor de vida muy en particular. Y después de haber vivido por muchos lados, yo no creo que ningún lugar es intrínsecamente mejor o peor que ningún otro, son diferentes. Cambia ciertas cosas por ciertas otras. Pero la habilidad de hacer lo que a mí me gusta, con todas las ventajas de vivir en Latinoamérica y que la sensación de familia y amigos y comunidad que tenemos aquí es muy diferente a la que yo he visto en cualquier otra parte del mundo. Aquí no hay que explicar por qué hay una carne asada el domingo. Es domingo. ¿Qué más vamos a hacer? Y llamas a la gente y te reúnes porque pues es lo que hacemos. Entonces es una forma de tener los dos y yo estoy muy contento. Yo me vine para acá a hacer lo que yo hacía allá, no para hacer algo menos divertido. Tenemos cosas muy interesantes. Tenemos proyectos donde gente que se ha graduado del SemDep ha hecho investigación, que ha terminado en el mercado y que estamos usando. Y hoy vamos a presentarles algunos de los proyectos que tenemos, pero solo es un pequeño ejemplo. Todos nosotros somos muy técnicos, entonces cualquier pregunta técnica que tengan nos pueden preguntar. Y esto es para ustedes. Ayúdennos a que hagamos un buen trabajo y que les saquen el mayor beneficio que puedan.
Tengo una pregunta. Yo soy Michele, Riviere, mucho gusto. Le voy a hacer una parte de la presentación hoy con Erik. Como usted puede ver, yo no soy mexicano, yo no hablo muy bien español, bueno, hablo español, pero para mí el tipo de presentación que yo hago, que es muy técnica, es mucho más fácil, sencillo para mí en inglés. ¿Es un problema para ustedes si yo hago esta parte en inglés o prefiere mi portuñol? Porque yo hablo portugués. Usted me dice, ¿eh? Entonces lo hacemos, puedo empezar en inglés y a veces cambiar, pero yo quiero, para mí esta presentación es para ustedes. Mismo que es más fácil para mí en inglés, es más natural. Si al final con mi español es mejor, lo hacemos en español, si no lo hacemos en inglés. ¿Okay? Bueno, empezamos en inglés y usted me dice. ¿Ok?
Okay.
Y somos un pequeño grupo hoy, que es perfecto. Entonces, y tenemos un poco de tiempo. Entonces, más o menos en mi presentación, por favor, si usted tiene pregunta, levanta la mano y con mucho gusto podemos hacer una... Tengo 3 partes. Vamos a ver lo que podemos hacer en el tiempo que tenemos. ¿Okay? Tengo una presentación sobre Vector AI y Generative AI, y una parte sobre Graph, Property Graph, y el último es JSON Duality View. ¿Okay? La parte más importante para mí es AI, Vector AI, Generative AI. Si tenemos tiempo, vamos a hacer las dos otras. ¿Okay? Y al final podemos también platicar si no tengo tiempo de... Muy bien. Disculpe.
No, gracias. ¿Quién aquí es estudiante de maestría? ¿Y de doctorado? Perfecto. ¿Y maestrías en sistemas distribuidos? ¿No? ¿Inteligencia artificial? Okay.
Ciencias de cómputo.
Bueno, ciencias de cómputo, pero ¿qué enfoques? Nada más, a ver si rápidamente más me dicen su enfoque. Empezando acá.
Yo, criptografía.
Criptografía.
Inteligencia artificial.
Inteligencia artificial.
Sistemas colaborativos.
Okay.
Criptografía.
Criptografía.
IA.
¿Qué?
Inteligencia.
Inteligencia, ok.
Inteligencia artificial.
¿Qué?
El mes doctorado, pero con bioelectrónica.
Electrónica, excelente.
Química.
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 Bastante de química.
Ok.
Ahí son postdocs.
Postdoc, excelente.
Yo solo quería conocer los proyectos que tienen.
Ok, excelente.
Yo estudio en el primer cuatrimestre.
Ok.
Llevo materias de... Hay unas cosas de sistemas distribuidos.
Ok.
Química también.
Química.
Yo estoy haciendo mi servicio social, pero en el área de criptografía.
Excelente.
Yo soy estudiante de primer cuatrimestre de la maestría.
Ok.
Estoy en los últimos semestres de la licenciatura, pero me quiero dirigir a IES.
Ok.
Yo soy de biofísica.
Biofísica.
PLC.
PLC, ok.
Yo de informática.
Informática. Excelente.
Computación evolutiva.
Evolutiva, ok. ¿En qué área estás haciendo maestría o doctorado y en qué área? Postdoc. ¿En qué área?
Computación.
Computación. Okay. ¿Pero qué especialidad?
Computación cuántica.
Cuántica, ok.
Yo soy la doctora Shaoli.
Excelente.
Sí, perdón, es que equivocamos. Pensé que iba a recibirlos allá y luego los acompaño acá.
Disculpe.
No. Yo soy la doctora Lee del Departamento de Computación. Trabajo a partir de 2005 en área de minería de datos.
Okay.
Y luego aprendizaje automático. Todo eso es lo de moda seguir hasta hoy. Sí.
Y gracias por haber venido por nosotros y disculpen de que nos pedimos.
No, recuerden nuestra conversación, ¿no?
Sí.
Gracias. Bienvenidos.
Gracias.
De mi primer cuatri.
Ok, excelente. Bueno, dejamos presentar aquí el grupo. Bueno, primero, este es nuestro centro de desarrollo, todo es el equipo que trabaja en el motor de base de datos. Creo que algo único que hacemos, pues somos, no sé si pueden apagar estas luces acá arriba.
Las que están al lado de la
pantalla. ¿No? Mejor. Sí, mejor. Bueno. Soy Erik Peterson. Yo soy mexicano, pero hice mis estudios en Stanford, Computer Science. Yo entré ahora con de recién egresado, empezando en México, pero después me regresé a California. Y igual creo que la creación más interesante que me ha tocado pues, ha sido crear el centro aquí de desarrollo de Guadalajara con Michele y Juan Pablo. Y lo interesante es que ahí estamos creando los futuros productos de Oracle. No estamos haciendo nada para el mercado mexicano, no estamos haciendo implementaciones para clientes, aunque hay obviamente muchos clientes en México. Estamos creando los productos que Oracle va a usar en todo el mundo. Yo creo que es interesante porque no conozco ningún otro igual empresa mayor que está creando los productos más importantes aquí en Latinoamérica. Si piensan cuál es el producto, porque Oracle es más conocido, es la parte de base de datos. En base de datos ya tenemos 600 personas colaborando en él. Y pues aquí ves a los 3 líderes más seniors en el acá. Aquí está parte de nuestro equipo, igual después de un evento de integración. Juan Pablo ya se presentó. Juan Pablo es muy geek. Le gusta mucho Star Wars. Tenemos un piso de pura temática de Star Wars. Okay. Michel, siendo francés. También de hobby. What do you want to tell about your hobby?
Oh, sure. Well, I like to cook a lot, and I'm also a geek. I'll tell you more a bit about me when I start my presentation, because I think it's, I like to share a little bit my background, what I did before, because I'm sure some of you may relate to some extent. But and I think at the end of the presentation we have very few perks. Do we still have some or not?
Depends if they arrive.
Some more.
Hopefully.
They're on the way.
They're on their way.
And so you can actually earn a lot of special gift if you find out where I'm from. So this is at least 2 t-shirts.
Yes.
All right. So
you guess where he's from. So besides high scalability, high availability, and human-computer interaction, which is my master's in, I also have a personal interest on tree management. And we give courses on how to best manage trees in an urban area. We also have with us Paola. Paola is our campus coordinator on recruiting. Her first time visiting SEMDep staff. I've been here several times myself. And we also have, Abraham's going to come here later on. Abraham's not here right now. Abraham's doing some AI projects, and we want to share some of that. And Yanni as well. Yanni's over here. Yanni did do masters in Seek, right? Yes. So he's working on a super neat project as well. Oracle is the biggest enterprise software company in the world. You may not have heard it as much commercially because we're more focused on the companies. We don't sell to consumers. But basically, behind every main business that you guys use, there's Oracle behind that. Let me give a few examples. I'm not going to talk, they're obviously the main clients. For example, Lawrence Livermore Lab, their National University facility. This is a project where they're trying to create clean fusion. And all of the projects where there's, how are they trying to create clean fusion? Because, we have fission, nuclear fission. That's where you take plutonium or uranium, you're splitting and getting energy out that way. Fusion's the opposite way, where we're actually taking hydrogen and you're bombarding it and trying to create helium from it. This is a much cleaner form of nuclear project. This is an experiment that's been going on for about 30 years. I've been fortunate to be interacting with them for about 15 years behind this. They have 192 lasers that are aimed to this point here, and it's smaller than my fingernail. And in that experiment, they are they're trying to get to the point where they can create more energy than they put into it. So it's self-sustained and be able to generate energy. For the first time ever, in a controlled fashion, they were able to do this last December. The first time we're actually getting clean nuclear fusion energy. And this has been proceeding since. And obviously, all of this data they store, they have to store, they get terabytes and terabytes of data from every experiment. Every experiment takes a trillionth of a second. So obviously, you have a huge number of sensors there, and they're trying to see what it is to reach that success. They have to keep tweaking on that part. And each of the experiments is stored in an Oracle database as part of it. So again, they're not only used by the big enterprises, they do things like this. Are any of you guys gamers? So all the online games. How is an online game possible? There's big databases behind that. You go to Square Enix with Final Fantasy, you go to Electronic Arts, all of those, there's big, it's a big database that you get into. What your username is, what are your characteristics, what gear you have, where you are, who you fought, that's all in the database. And I had the fortune to actually help create EA's our architecture for their first version of Sims Online. Back then. Maybe in pandemic, you had to do classes by Zoom. How did Zoom scale? How did it go from a smaller company to a massive environment? They actually used our cloud infrastructure to scale out wide and be able to host your classes online. Or you order stuff online, be it by FedEx, be it by, you order from Mercado Libre, you order, again, even the payment form that you do Visa, you do MasterCard, etc., it's on there. Talking anything about payment forms, which of you are interested in blockchain or Bitcoins? One thing for us, being software developers, scalability is very critical. For example, a challenge I have with Bitcoin, okay, how much energy does a Bitcoin transaction take versus a transaction on MasterCard or Visa, which both run on our environments? You need 1 million times more energy to do a transaction on Bitcoin than you do, a Visa transaction. So let's say, is that going to scale? Is it going to be able to take over transactions? Well, you need 1 million times more energy. What would that do to the world? Obviously, we do databases, applications, cloud. We're actually one of the fastest growing cloud vendors right now. Again, we're Microsoft and Amazon were first, but because companies rely on us for their data, the most important data in the world companies have is all in their Oracle databases. We're becoming much more popular for them to use as well, and we're increasing. On the application side, which we're not part of, which is as background, we're one of the biggest application vendors, both in application systems like financial, HR, but also on systems, for example, for you guys, for your phone, you get a message. How does the phone company know you actually have datos? The system that authorizes that, or authorizes your phone calls, is also an Oracle application. Michel?
Yeah.
So you're going to start, and then I will talk more afterwards.
Absolutely. Right, so I'll present myself a bit more, because I think it can be interesting for some of you. So I joined Oracle around 18 years ago. I studied in the Bay Area, close to San Francisco. This is where the headquarters were. Before working at Oracle, I was working, maybe some of you guys remember Netscape. So I worked at Netscape. And before that, I worked in research, applied research. I was at Xerox PARC for some time. And before that, I was in the academy. I did my master in computer science and distributed system at Grenoble Polytechnico in France. And I did my PhD also in distributed system and parallel system in Grenoble at the Université of Joseph Fourier. And I've done 2 postdocs, one in New York at Watson Research Center for IBM, and also in Rio Grande do Sul, where I worked at URGS, which is a major university in Brazil. That's where I met my wife, that's where I learned Portuguese, and that's why when I speak Spanish, it sounds more like Portugal than, All right, but the point here is, when I joined Oracle, my background was not database. I was more like, I was, I think, a solid developer. I switched from the academy to the industry, but I always liked more the low-level layers of the stack. So basically building operating system, distributed systems, virtualization, networking, high performance. This is basically my interest. And so when I started to talk to Oracle, because I knew at that time someone there, and they told me, Michel, you should apply with us because you could do something very interesting for us. And I said, well, you're a database, right? I knew that they had application and other things, but why the database? It's because we have a lot of different layers in the database. And we have one called virtual operating system. And I said, oh, that sounds interesting. Tell me more about it. And so that's where I started. Virtual operating system, basically this is a layer that abstracts the hardware and the operating system. Right? Nowadays, it's not as much of a problem as it used to be, but back in the days, when I say back in the days, it's around like 15, 20 years ago, Oracle had to work on maybe 20, 25 systems. Nowadays, it's mostly what? AIX, Solaris, Windows, Linux, and we still have HPUX. but it's going away. Before we had many more platforms. And also on the hardware side, I didn't know that, but you know, there are a lot of teams working, you know, with Linux kernel development. Oracle actually has a Linux kernel team. We also have a virtualization team that works on and does patches and features for KVM, for Xen. We have also, you know, partnership with hardware vendors where we do basically low-level, you know, communication protocol. I worked for some time on, for example, RDMA protocols, where you know, the goal in a distributed system is for a database is really to exchange data, right? A database at high level, it's a big cache, right? And so when you have a distributed cache, you know, you really want to make sure that you update and read the cache remotely as fast as you can. And as fast as you can means basically typically zero copy. RDMA is the way to go, okay? So we do also a lot of cool stuff. And the reason I'm mentioning this is because I don't want us I don't want you guys to think, oh, you know, Oracle is only database and application and whatnot. I mean, we do a lot of different things, you know? And so today, I have 3 parts. I'm going to start with vector AI and generative AI. And after that, if we have some time, I'll talk a little bit about property graph and graph in the database and JSON. And the reason why I choose this topic is because, one, I know that you are interested in AI. Okay, again, this is not my background, but at least in the presentation, I think I should be able to navigate, you know, what it is about, at least in the database. But the goal was really to show you that sometimes we have this, you know, ideas about, oh, a database is just a bunch of tables and people running SQL against it, right? And that's why, you know, smart people came in and said, oh, you know, we can have different type of database, that pure relational database like Oracle. Again, Oracle has many, many databases. And when I say Oracle database, I'm talking about the Oracle RDBMS, right? And so, you know, you started to see other type of database, right? Database for document, for JSON, and MongoDB, you know, and other database for graph and so on. And Oracle basically decided to support more and more types of data, right? Ranging from JSON to graph, and now we have this vector AI, right? And it's just kind of an example of we're always trying to see what we can do in order to support, you know, not only what's new, okay, but what can make a difference. And I hope that after this presentation, you can see, you know, the possibility. And very often, you know, people realize that, oh, that's cool. Oracle put the graph, you know, the graph data type, or you know, the vector AI, or you know, the JSON document, right? Then you can query the database and just, you know, get a JSON in the document, right, instead of a bunch of rows or columns. But that's not all. That they usually it really gets interesting is that when people realize that not only you get, you know, all these new cool data types in the database, but you can mix it with traditional SQL query constraint, right? And in the case of vector AI, and I'll talk more about that, you can combine unstructured data with structured data queries and management. That's actually really cool, right? And so, because I give you a challenge. If you have a JSON database with, JSON document with multiple fields, right? And you want to ensure that one of those fields you can ensure like ACID property on it. With, you know, that's kind of hard. But if it's based on a relational database that provides these ACID properties, then you have it for free. Kind of cool. Anyway, let's start. As I said, feel free to interrupt me, ask any question. I think we have time, and I really want this to, I kind of know this stuff, I really do this for you, so if we want to branch on a few things, I'm fairly open. Okay? All right. English is good so far? Okay. Right, so I'm not going to go through this first. I'm going to start with AI search and generative AI. So it looks like some of you guys are you know, interested in doing interesting stuff, I'm sure, in, you know, with machine learning and AI and so on. So, again, as I said, this is not my field, but I think this is something that is really interesting, and I want to talk a bit about it. After that, we go to graph and JSON, and actually those two new data type. I would say half of the team that worked on it is in Guadalajara, in my organization, and I'm really proud of what they've done. So hopefully we can talk a bit about it. But this part was done actually in the US. It's not yet publicly available. It's going to be available in the next generation of the database, whereas the graph and JSON and other data type, you know, fancy data are mostly available in the latest version, current, including the free version. This is basically available next year. All right, so I think the goal here is to show that with vector AI and generative AI, combining the two, we can give, you know, developers, data scientists, the low-code app developer, or the end user, the ability to use natural language to ask a question, right? And this, and not use a programmatic API or SQL or whatever, and that basically you get some answer back. So hopefully at the end of the presentation, we'll close the loop, and you'll see how we do it in the database. Okay? All right. So, unstructured data. Okay, so we're all familiar with structured data. You know, in the database, you know, you have tables and rows and columns, and you have standard types, you know, numbers and strings and whatnot. For managing unstructured data, like images, or, you know, music file or documents, right? How do we do it? Well, one way to do it is to use vectors, right? And so, for example, when we, thank you, if we want to basically put some image in the database, pictures of faces or houses, for example, now we have this new data type, AI vectors, that allow us to put this unstructured data in the database and do query on it. Okay, so it's not a, you know, it's not a blob. We also have a blob data type. A blob data type is, you know, in a table, it's one column, and you put whatever, binary blob of whatever. But it's completely opaque for the data. It doesn't know what it is, right? Can't do any operation. With this, you can start to put pictures, documents, music file, and other things, and we'll be able to do some operation with it. Okay? All right. And any of you guys are familiar with AI vectors or not? No? So what is an AI vector? I mean, at a high level, it's really simple. It's a vector with a bunch of dimensions. A dimension is basically one of those numbers, 33, 42, 16, and so on. A vector could be tens or hundreds of dimension, up to 1,000, doesn't matter. It can be small or big, right? If you're interested to know more, for example, about, you know, how you generate those vectors, right? I'm not going to cover this too much, right? Because it involves machine learning, you know, neural nets to generate those vectors. So I'm not going to cover this. But typically what it involves is you start with images, document, video, music file, and whatnot. So you have your documents, and then you have a neural net here that produces those vectors. Okay? One thing that is interesting, for example, at least it helped me understand it a little bit more, you have a project called OpenFace and FaceNet. You can check them out. And you know, what they do basically, they provide, you know, this thing here that kind of convert at least pictures, face pictures, into vectors, right? And in their case, they claim, for example, that with 128 dimensions, they can do pretty much, you know, pretty good job at face detection, right? So they will take hundreds of picture of you, right? You know, in different poses and whatnot, and they're going to have hundreds of vectors for your face, and then this will allow them to kind of detect, for example, predict if we have another picture that is close. I'm going to cover this, but a bit more in more detail. But for now, a vector is basically a bunch of dimensions that capture the features, right? So I talk about a face, but it could be anything, really, right? Could be a document, could be music, and so on. Now here, this is an example of a house, right? So features could be, is this a wooden or bricks house? Is this, how many stories, and what style it is, and what are the materials, and what. So, the more dimensions, the more features you can cover. Okay. Before, with traditional tables and whatnot, people would do this by hand. They had a big table, and they would define, like multiple columns with all the features, and manually do it, right? Now we don't do this anymore. Now what we do is we just take a picture, put it through the neural net, and we have this nice vector. Okay, and so that's basically the idea of how you generate a vector. You use machine learning neural network, but you don't have to specify the feature. So typically the engine that you have will be specialized or do a better job to kind of go after some type of data. And it's a pretty big business. Like we are working very closely with Cohere. I don't know if you learn about Cohere. It's a company that is specialized in doing this kind of thing. Basically translating, different type of data into those vectors. All right, and then any questions so far? Okay, so when we have those vectors, we can project them in the 3D space, basically 2D, and then what we can see when we project them in 2D is that the vectors that are similar tend to be close to each other, right? So, same type of houses. If I take 100 of pictures of one of you, most of them will be, clustered together, okay? And things that are slightly different tend to be further away, right? Thank you. So again, we use kind of the distance, between those vectors to define whether they are close, similar, or, different or not similar. Okay. If we apply this not to pictures but to words, we can also feed those words into some model, and we get those vectors for each word, different vector for words. Words that are semantically close, like fruits and animals and whatnot, also will tend to be together. Okay, or at least we can make it happen. Okay, and this can be applied not to words or picture, but also to very complex documents and big documents. Okay. Okay, so now that I presented very quickly what are those AI vectors, that help us kind of store in the database in structured data. I want to show that we can also do operation on them, on those vectors, and we can also mix or combine operation on those vectors with what I mentioned here is business data is basically like traditional, constraints that you would do, search on a relational database table. These are also the few examples that I grabbed that we hope that we'll be able to do well. So with these AI vectors, so I mentioned face recognition, but this is basically everything. A lot of things that you can do around image or even videos. For example, finding defects, right? You take pictures of glass, and if you see like there's a break, so this kind of thing, right? And then, of course, I mentioned that we can actually use or put documents through those neural net and get pretty large vectors usually that basically can help us do some queries that allow us to find if documents, for example, are related to each other or if there is some overlaps in them. Right? We hope also that we'll be able to do banking, for example, kind of try to also with graph kind of find some pattern analysis, fraud detection, these kind of things. Okay. So point here is basically we can put in those vectors a lot of different type of data, and we think that there are a lot of scenarios that can be useful. All right. And then here I want to show you like a practical example, and this is again this is working. This is something that we have in house that is going to be available early next year. This is how you create a traditional database table, okay? And these are the columns: house ID, price, city, house photo. The house photo is a picture, the blob, the bytes, the bits, right? And then it has this vector, okay? So this vector again, this is, think like this is a table. Each row of the table will be a house, and for every house we will have a different vector, and we will compute this vector using a neural net, engine, not OpenFace or FaceNet, but something similar that will process all these pictures and then generate this vector. So we have this big table, and one column. So the small table, sorry, we have one, the last column is the vector. And this will allow us, now that we have created this table, to run some interesting query. Right? So the first query is, right, so house for sale is our table. Let's say, we are a real estate agency, we have 1,000 houses, right? And, so from houses for sale, these are all the house vectors, like all the vectors from all the 1,000 houses. And I take a picture of a cool house that I like, and I want to know if you have, if the real estate agency has something similar. So this is a picture vector of the house I like, and I select and see, okay, vector distance. And I order by vector distance. So the smaller distance, the closer it's going to be to the picture of the house I like. Easy to understand, right? Pretty easy. And so that's how, this is a very simple example, but hopefully it helps you understand that by using this kind of operator, vector distance, which by the way, is the only operator that we provide. That's it. That's enough, pretty much. And what we can do, because we are still using the Oracle RDBMS with all the features and all the ability of running complex queries, and we can mix basically business data coming from tables such as, okay, there is a customer table that has, for example, the price that you're okay to pay with, right, and the city. Because here we return any house from anywhere, okay? So here you can do traditional, constraint where you say, well, this is my price and this is where I want it to be. You can, and this is pretty easy to understand, pretty simple. You don't need to be an AI ML specialist, to do that. Right? The complex thing is really to generate those vectors, by the way. But we can also have, hopefully I have time maybe to talk a bit about graph, but graph is actually doing graph manipulation, but also spatial. There is actually the group is called spatial and graph. And spatial, what they do for the database is that they have a lot of operators that allow us to do, for example, spatial localization and whatnot. So you can even say, you can give a GPS localization or city, and they can actually, you can say which neighborhood and so on. So you can actually use other features of the database, like spatial features, to kind of refine your search and help this, right? So it's really coupling the AI search with on those AI vectors with other features about it and traditional constraints. All right, and then I mentioned that, so I just mentioned there is one operator. So what we do have is we have the AI vector, the distance operator, right? And to make things, some of those distance computation, we have vector indexes. That's it. And we think this is sufficient for many scenarios. Maybe we find something, but right now that's a plan of that we have. So that's basically our story on AI search. Introducing this new data type, the AI vectors. We think we can actually put a lot of different type of unstructured data, and with this simple operator, we'll be able to run a lot of the scenario that I just mentioned. Not only the house sales and so on, but also like detecting, most of the examples I mentioned. Okay. All right. So. Sure.
Just a question. This distance operator, it is measuring with Euclidean distance, or how do you measure this?
No, it's not. It's easy to understand the notion of distance when we project in 2D, because our brain is. But if it's when 3 dimension, we can still kind of but it goes beyond that. It's hard. So projecting, but I think algorithm is not projecting and doing. I think they're doing something. I don't know the detail.
Okay. So it is always the same kind of distance. Can you? But
it's. Sorry, what I meant to say is that the notion of distance is how far they are. So it could be just an integer or floating or whatever, right? But I'm not sure that they project it they project it and then compute the distance, or there is something else. I don't know. But in the end, it's a distance. Yes, it's a value which is how far you. But the reason I'm hesitating because I think that there is it's not only 2D, right? So that's why it's easy to understand when I map it to 2D, but and in the end, it's a distance, but it's, it's a multiplex.
Yeah, there are many ways to measure distance.
Correct.
So that's why I asked.
So I don't know the detail. I guess that's a short answer. All right, so now that I presented quickly the vector, AI vector, some of the operation that the operation that we can do on it. I want to quickly go over what we can do when we add generative AI. Okay, so we've seen AI search, okay, the search part. Now let's see how we can combine this with generative AI. So the goal is really to be able to allow developers and users and whatnot to use natural language, like you would do with ChatGPT and other, to kind of express in natural language a question, and then basically you get a meaningful answer. Okay? So generative AI, as you know, they're already doing a pretty darn good job, at least answering some of those questions. So what we're trying to do here is to kind of, not only refining your model with training, but we look also at augmentation. Okay? And so one way to do this is basically once you have this new data or this AI vector, you can use this to enrich, basically augment your model, right? Because training is limited, right? When you do training, you can't do training every minute or every millisecond. You can augment very, very quickly. So you won't refine, training will refine your model, but if you want to augment it, enrich it, that's where actually augmentation. So the way we do this, and I think an example is maybe easier to capture. So that's basically what I just mentioned, right? So we use basically vector database to augment the Gen AI. And in my view, this is going to be big. If you've not, maybe some of you have heard about it, RAG, Retrieval Augmented Generation. This is big because it's going beyond training. It's really how to really augment, enrich the model meaningfully. And so one way to do it is, for example, the database side is we think, what we are trying to do, because this is still what we are working on. A user will ask in natural language a question, a query. This will be translated, breakdown into the different stage, and then eventually we'll get to a vector. This vector will be sent to the database. We'll use this vector, right? Like the picture of the house that I mentioned, go against not thousands of pictures of houses, but against documents, right? And we try to find those documents that are closely related to the vectors that comes from the question from the user. And then once the database found the document that seems to be somewhat related based on the AI search, comparing the vectors, it will send to the Gen AI the documents, not the vector of the document, but the documents with the question to the Gen AI. And this will allow the Gen AI to do two things. One is to give a more meaningful answer to the user, okay? Because Gen AI tend to have generic information. Our database can have very private, sensitive data of companies and whatnot that you don't want, that you can, So, but you can enrich your generic model, and the Gen AI should be able to do a better job answering this question. All right, so that's more or less where I close the loop, okay? Where AI search in the database, combined with generative AI, what we think we'll be able to do, okay? Of course, we are looking at other things like using generating AI to generate codes and queries, so that ends my presentation on AI search and generative AI. Any question?
Do you use the autoencoders to generate the AI vectors?
Sorry?
The autoencoders to generate the AI vectors?
Transform. This again, that's I know some of the engine that we use, some of the neural nets. I'm not a specialist, right? So I can't really answer that.
I think that the point here is, again, to encode the vectors, you can use any encoding mechanism to create the vectors. We're only storing the vectors in the database. Whatever things for different types of videos, images, whatever vectors you want to use, you can use any encoder out there to create the vectors. We just store the vectors and compare.
Yeah, exactly. So I know that some engines are better at processing pictures, for example. That's why I mentioned OpenFace and FinNet. Now, what algorithm they use, that's not my field. So I cannot answer that. Right? So.
But again, it's flexible. We don't, as we're storing that in the database, we don't care what mechanism you use to create the vector. You can use these different mechanisms to do so, change the mechanisms as you want them, but then we can optimize the search behind the scenes.
Yeah, but not every generated vector is going to be useful for your database.
No, so you have to figure out which ones work. But again, that's
the hard part.
That's hard,
of course. So again, it's not an easy thing. But again, it also evolves. We don't want to bake something in if it's going to keep changing. So yes, we might have some simple things in there. But again, you can have this. We could have an external function call that calls to your vector creation, or even you generate it outside, and then we pull those vector numbers into it.
Yeah, and plus, once you generate a vector for a given set of data, if you use another method and you generate different type of vectors, then you will have to kind of go through the whole thing, right?
A vector for face recognition may be different than one for house optimization, without houses you want. So again, you're going to have vector generators that specialize in different things. But yeah, you have the flexibility to do that on the application level.
And we'll also kind of, I mentioned this company, Courier. And we're partnering with them in order to, my understanding is to provide, at least for some type of data, pictures and whatnot, the ability to generate vectors that are, good enough to do, queries, right? For, search on pictures and music and documents and whatnot. We'll see. Thanks. Any other question?
What about the competitors? I mean, which kind of database does?
This is a very hot thing. This is a very hot topic, right?
Yeah.
Very
So,
hot topic.
do you know which kind of
I don't remember. I have it in my note. I don't remember. Sorry. But if you Google, vector AI, you should actually. It's a very hot topic right now. There are like 1 or 2 companies.
I think there are several startups that are focused exclusively on that.
Now, the interesting point is, whenever there's a new database management method, they come up startups that focus only on that. So you have databases that just do, JSON documents. You have ones that just do graph. You have ones that just do these things. But you don't have the advantage in Oracle, so you have the flexibility to do this all together. So if I want to do a vector search, combine with a graph search, combine with JSON documents, combine with relational data, I can do this all in one place. Or I can even outreach to these different, the different data sets.
Because my understanding is that, at least from the team, not underneath, but from the team that worked on the vector distancing, right? Basically manipulating those vectors, and I don't know the detail, and I told you, unfortunately, I'm sorry about that, but what they told me is that it's not super complicated, okay? What is complicated is generating those vectors. The distance thingy that I mentioned, this is not the hard part, right? So, but for us, it's really kind of, yes, you need to generate those vectors, put them in the database. We provide the distance operator, but after you can combine it with so many other things, and that's the value. That's the real value.
So imagine you want to do that house search. You want to do a house of the style you want to buy. You want it to be within 15 minutes of the driving time. So it's now a graph search there. You want it to be within your budget. Other factors that are, so you combine these different data types, which you would not combine, if you have only data that does one thing, you can't do that. So that's, I think, the real powerful thing. I think the other thing that's really powerful is that and especially when we get into, well, are you talking about the generative SQL and stuff like that or not?
No, the generative SQL.
Okay. But when you get into some other things like generating SQL, generating things up on there, is who do you trust with your data? Because you talk about let's say you talk a big bank, or you talk, again, Movistar. I mean, if you want these generative systems to work well, they need access to the most recent data.
No, I talked about augmentation.
You did
but the SQL generation,
yes.
I didn't talk about.
Yeah.
But I talked about.
But now, and with that, you want to be able to get access to your production data, to this most recent stuff. You're giving access to your crown jewels as a company. Who do you trust to do that? And a big advantage we have, because we run their production environments, for the most sensitive environments, so they already trust us from that perspective. It's much easier for us to expand upon that.
And we can do it in our cloud. We can deploy our cloud in their environment where they have full control,
yes.
Or they can choose to do it all themselves if they want to suffer.
And those of you who are in cybersecurity, I mean, the aspect of trust is critical. I mean, because again, you're going to let them look at all your clients, all your customers, all your transactions. You're not going to let a random startup, let me snip all your data out and I'll give you recommendations. Like, no, you have to be much, much more careful about how you do that.
That's why I can close the. Do I have time to do a bit more? Or
Yeah.
So I here put together like some of the question answer that were asked at Oracle World this year about the impact of generative AI, and this is going to replace experts, right? think pretty sure most of you already know the answer. No, it's not. At least not in the short term or the midterm.
Some of them.
Sorry?
Some of them.
What?
Some of them.
So I think today's Gen AI, I mean, they can't yet generate a complete solution. I think they do a pretty good job at defining that blueprint, skeletons. The metaphor that we often use is basically it's like the super duper intern, right? You give him a question, he's super smart, he works really hard, but you need an expert to review the work after that. But that already saves you a lot of time. Okay. So, for example, I mean, this is because when we're asking, oh, is this going to, do everything? Of course not, right? So, and then this is also the part of that we get questioned on because we generate a lot of code. We write a lot of code. The question is, can generative AI generate code? What is the answer? I mean, ChatGPT, you ask a question, write me the code of this and that and generate us, like 100, 200,000 lines of code, that's fine. When you have a project that is 500, 1 million lines of code, and if it's produced by an AI, you still need human to support it and fix it and extend it and so on, and this is a nightmare. People who write the code tend to know it, or at least pass the knowledge. So that's, maybe we'll find a solution. And again, this is more short-term, but that's actually some of the problem we have on our side with code generation. And that's what I mentioned. Like even if the AI would be able to generate like really good code, you still need people to understand it, trust it, validate it. Wait, I'm using it a lot, but again, that's more like let's say like the framework, skeleton. All right, so that's going to end my section on AI. I wanted to cover maybe quickly, because I know that Erik wants to talk a bit more about further things. So I'll should be pretty fast on those slides. So here the goal is really not to go into too much detail, but really to show you that, like we have with AI vectors, we have other data types like JSON and graph that you can put in the database and combine them with, traditional, queries and data manipulation that we offer with the database, right? So you're not restricted by traditional tables. So the reason, for example, behind JSON support in the database is because at the end of the day, what is important to us is also that our user can actually develop the application and and the way they like, or the way they think it's more natural or more convenient, or sometimes they develop an application. We have a lot of customers that use MongoDB, which is a document database, for example, and how they move, if they want to use Oracle database because they have other data, how does this work, right? You don't want, if possible, not to have multiple database, right? So, so that's why that was some of the reason why we decided to kind of have JSON support in the database. Because, again, a lot of developers, they like the document database because they do a query, they do a get, and they get a JSON. And the JSON, when you can hear, you see, it already has everything, right? It's nice, right? Just do one get, and if you use Python, you can translate this into a dictionary. Dictionary, and that's really cool. If you use traditional tables, well, you're going to have to do a bunch of queries, select, and so on these tables, that contain all this data to get that. So, in an ideal world, well, you'd like to be able to store in the database, using tables, the content of your JSON, but able to put and get your JSON using an API that manages only JSON and not do the query. So that's, for example, the amount of SQL that you need to write in order to define the schema which is very interesting because JSON was supposed not to have a schema, but basically the schema corresponding to this document. Basically we can define using this SQL statement a view, which basically is a way to define the JSON structure, right? And all the fields, basically. And then those fields will be mapped to tables, right? So that's the same SQL statement, but you have the mapping to the table, right? So this is the student table, this is the other courses, and so on. And so basically these come from the related tables, right? That's how basically you define the schema on the view of your JSON document. And once you have this, well, you can just use an API to do put and get of this JSON. And you have not only the advantage of having an API that allows you to manage direct to query, update JSON document in the database from an apps perspective, but you can also, because the data is stored into tables, right? What is one of the big advantage? What is the first big advantage that you get from that? Pretty easy one to kind of figure out. It's duplication of data. You don't have duplication of data because if you have a JSON document with the same fields, right, you duplicate the data. Whereas if you store this into a table, you have only potentially one row of the data. Okay. So if you need to change, for example, here this is the schedule, of students. If you need to change, for example, the room, well, you don't have to go through every document and change the room. You just go in the table and change one row. That's it. Okay. So here that's basically just mentioned that we have an API that is basically compatible with MongoDB. We have REST API, so basically very similar to, not only similar, but like compatible with one of the most known document database, Mongo. And here this is basically the point of showing that there is no duplication. Right? It looks like when you query, that you will have for both students, you will have two different JSONs. But this data is the same and it's stored only in one location, so you don't have duplication, unlike the traditional document database. And of course, you can combine this with, this is graph. You can combine this with, while you use the JSON API, you could have another app that accesses directly the calendar, the courses and whatnot using traditional SQL. So that's actually pretty cool. You can combine both. All right. This here is just more the one example of this converged database that we want to be, right? That Oracle really wants to be a database that is not a kitchen sink, but we support a lot of different data types that are meaningful. And so if we see that a lot of developers are starting to use JSON, then we support JSON. Same for graph. That's a few slides I have on graph, where it's really hard to manipulate graph if you put them in the traditional tables. It's hard because typically for representing a basic graph, you need two tables, one for to store all the vertices and then one for the edges. Right? Again, this is a simple example. But to manipulate graph really, using select, it can be done, but it's ugly. So and graph now is more and more pervasive, right? You have the social graph and so on. But here I put an example of transaction, bank transaction, where the edges between vertices are a money movement transaction, right? And in order to represent this, in the database, if you really want, and that's a lot of banks do it, right? That's how I simplify, of course, but in the end, at the high level, that's how they do it. They have bank account, and they have the transaction table. But if you want to build a graph that shows basically all the transactions, right? Or if you want to walk the graph, doing this using select and one, it's very difficult, very complicated. So that's why we, similar to JSON, we have now the ability using very simple SQL kind of. This is SQL. We can create not a view. This is this new type called property graph, and we basically define the vertex and the edges, based on that we define where they come from, where they're stored. So here the vertex table has all the vertices in the bank account, right? And the bank transfer basically which contains the edges when they transfer in this table when they transfer. And then this is for the keys. And then once you create this, you can use traditional SQL select and in a day to walk your graph or do graph matching. Here this is an example where I believe what we're trying to do is we are finding the different money movement transaction between an account B and E. So the only new operator here is this operator called match, right? So this is not, this requires a little bit of work, but once you understand how it works, you can actually, in a few lines of code, do some pretty complex query on graph. And if you want to do the same using traditional SQL, using joins, for example, and unions, it's going to be really ugly. Okay. Tens and tens of. I don't even want to go there. I don't. So anyway, so that's an example of. Like similar to JSON, we can put graph. We have operators that allow us to kind of do query on the graph. If you're interested, you can find much more information on property graph within Oracle. And I'm really, really proud that both graph, spatial, and JSON, the bulk of it, a significant portion of this in the database is done in Guadalajara. Spatial and graph, for example, it's nowadays like 30 people. When I started the group, people were asking me, Michel, we need some people that, with a strong academic background, we want some doctors and masters in different fields. And we found them. Half of the team actually spatial, half of them have doctors. Right? So they do some pretty advanced stuff. They wrote a lot of patents. I think spatial and graph is one of the groups that joined most of them. Made a lot of patents in my own. I'm really, really proud what they've done. They started like almost 12 years ago, spatial. JSON came after that, and so this really helped us to show that we have the talent here. We have people that can work on really hard stuff that's used all over the world every day. Right. I'm going to close my speech here. Hopefully, you learn a few things about what we do. Not only in general in Oracle, in the database, but also, again, as I said, some of this stuff is done in MVC. Thank you.
You want me to close?
Sure.
No, you guys need to leave.
Oh, yes.
You have 20 minutes.
What time is it?
1:10.
Okay, so we have 20 minutes to talk, and then we can. So Juan Pablo can close afterwards.
We have
somewhere. The package has arrived. The package arrived, so we have good gear. You guys are some of the. This is our new T-shirts that we have. This is small. What ladies do we have that know that this looks like a Whoops. Oh, sorry.
I could get one.
Guy what?
Yeah.
This is us. This is a guy or a girl's cut?
No, it's a girl.
The girl's cut.
I want from the girl.
Girl over here. Whoops.
That's also girls.
So you think she's a feminist over here?
No.
Guys. Okay, so girls cut. Let me see over here. Up there. Oh no! Okay. Some guy shirts over here. Okay. Oh, wait. We should have you guys answer some questions. So, oh yes. Who can figure out where Michelle is from?
France.
France.
Where
in France?
Toulouse.
It's not metropole France.
No.
As you know, France, like the US, have the case of the US, for example, Hawaii is a state, right?
Okay.
So
So he's from France, the country. What continent is he from?
Europe.
No.
No, America. De Guayana.
What?
Guayana, francés.
That would be a good,
Guyanas?
that would be a good guess. That could be close, but it's not the one. No.
So what continent is from? Europe? What?
America, like
America?
Guadeloupe.
I'm not from Martinique, Guadeloupe, Guyana.
So again, he's proper French territory is not a colony.
Africa.
Africa, yay!
Right. So originally, I am from Reunion Island. That's where I grew up. That's where I come from. So look at the map. You see Madagascar. There are two small islands, one called Mauritius and one called Reunion Island. So
who remembers where I'm from?
Mexico.
You said it first. So let me see. Okay, I have to leave in 20 minutes. I'm going to jump a little bit back to some of the endpoints, and then Juan Pablo's going to come back and talk some more technical stuff. We also have several alumni and current students. So let me introduce a few of the other people. Abraham is here. Abraham is actually an alumni of ESCOM. He's actually doing machine learning work at Oracle. He's going to talk a little bit about it. Actually, let me introduce his part, and then let me jump ahead on some of this stuff here. Sorry that we have to jump a little bit of order, but I have to run over to Seek. So, okay. So let me talk a little bit about our campus, and then I'll put about there. But I mean, so one thing I wanted to mention is that one thing that shows how our work is very much leading edge, building product, doing research, applied research within our products is the amount of patents that we have. So we've only been there 13 years. Patents take about 5 to 6 years to generate from when you actually invent the things. We already have 32 patents issued, and we have 25 patents pending. Okay?
that we can talk about.
That we can talk. Well, yes. These are ones that, well, pending is that you've actually submitted. Submitted and they're in the review. These are the actual patent numbers. You can actually look them up, and you can see the details. But I'm going to highlight one of those patents. Well, I'm going to have Abraham highlight one of the patents afterwards. But again, I'm going to just show them the piece. You'll jump to them, and then I want to just kind of take them through. Actually, you can take them through the recruiting process, right?
Yes.
Yeah. So we'll have you do that part there. Just seeing how I balance. Unfortunately, the SEEK presentation starts at 2, and it's far away. And we don't have a car because you're staying, right?
No, I can also go there.
You can also go. So we should have you present, and then you take us.
Yeah, sure.
Do you have a car?
I do. Yes, he has the car. He's the one who brought us. Sorry, just a little logistics. But again, we really like coming here, and really because of the type of work that you guys do with your master's PhDs, it's the closest to what we do on our side. And obviously, we hope a lot of you guys become professors, become researchers here. For those of you who want to come to industry and want to stay in Mexico, we hope we're a great option. So within these parts here, and again, on what some of our patents, so Michelle already mentioned some of our patents are in the area of graph. But for example, we also have 3 patents in machine learning on the team that Abraham's on. So I asked Abraham to join us. He actually lives here in Mexico City. Now this project, this is his machine. So let's see. Michelle, where? where's your thing to start?
That's not my machine.
Oh no, whose machine is this?
The university.
Universities. Where do you start the slide mode? Sorry. Oh, and do you have a copy of the changes that you made so we can take it with? Okay. So this part here. So again, there's 3 patents that were generated when this thing got started. This project got started here in Mexico. So it actually got started by an intern. There's currently now 14 people on the project, 9 of them in Mexico. Abraham is one of those 9 to talk a little bit about it. And I think, again, it's exciting to show you guys another example of the work that you guys could be doing. Yeah.
So, should I think I should just go
yeah, just come up here. Yeah, thank you.
So, I joined Oracle thinking that it was just, working on Java, the Oracle database. And I was really surprised when I figured out that I ended up in this team that is called Adaptive Bug Search. Adaptive Bug Search is a project that uses machine learning to try to solve a problem that happens quite often in the industry. I'm just going to give an example right now here. Let's say you are part of Oracle, just in this.
I can talk from experience on that. They give you a bug. Some customer somewhere came up with this really bizarre, hard to reproduce problem, and you work at it because it's just a very hard thing that no one could figure out, and you spend 6 months of your life tracking it down just to figure it out that someone's already solved it. That sucks. He's my best friend.
Right. So, and it not only happens when someone already solves it. Let's think in an example where someone is working on it, and this specific issue happened for some of other customers, and this other customer hit it with different symptoms. It's the same root cause, but the symptoms are quite different, right? And this happens quite frequently in the history, and what we're doing right now is try to convey the stacks, the information, the symptoms that happens after a piece of code crashes, and use natural language processing as well as deep learning to figure out whether or not bug A matches symptoms B, or bug A matches symptoms bug B, right? And if that happens to be the case, we can correlate these 2 engineers working on it and say, well, pretty much you're working on this specific thing that this other engineer is also working on. So you might as well not work on it, right? And it also happens that when one of our customers hits an issue in, I'm just going to say, database 19C, and it turns out that in version 21C, that issue was already solved. With our machine learning models, we can figure out, hey, you don't need to file a new bug on that. You don't need to assign it to a different developer. You just need to apply this patch, right? And this is what we call patch recommendation, and we're also doing it. The project I'm part of right now, every once in a while, not once in a while, every Friday, we meet to figure out what are the state of the art in natural language processing, and which techniques can we use to improve the set of models that we currently have in order to improve the accuracy. So when you join this team, you always get updated, and you get encouraged to keep on with how fast natural language processing and generative AI as well as deep learning is moving forward, because we want to try to solve this problem as well as possible. So it's a very exciting project. It can extrapolate in some other ways. So for instance, figuring out which are the top files that Oracle needs to put attention on in order to tackle the most number of tickets in the future. And you can do all sorts of things with this data once you have figure out a way to represent it in a way that the machine learning models that we use can play with it. So we are actually working for people that has a lot of computer science, hard background, but also has knowledge in this database field, and in this machine learning field, and is interested on working on these experiments that we're doing. So yeah, that's that.
Thank you, Abraham.
Thank you.
So Juan Pablo is going to stick around. Paola as well. Also Rosaura, where's Rosaura right now? Rosaura is actually doing her internship with us. She's currently here in the staff. I'll have her share some of her experience as well. just before either myself or Michelle leave, any questions you have for the two of us? Well, thank you so much for being here. You're going to be in very good hands with them. Give them all those hard questions. Keep those things up. And again, you know, for those of you early semesters, again, you know, we want to keep up the interaction. Thank you.
Thank you.